All right. So a little bit about methodology. We now know actually roughly what we want to do, but are there rules of thumb that help us throughout the design and throughout the automation of our operator? And yes, there are those principles that we found meaningful automating several data services over the years. First, you have to know your target audience. I mean, obviously, we've been through a list of things organizations will want, and you know, gathering this information is knowing your target audience is essential to the automation. Choosing data services wisely, if you can choose them, if you're, depending on the organization you work with, it could be that your application developers have the choice and you have to provide them the automation they'll want. However, if you do have a choice, choose wisely, because beside of technological issues, for example, Postgres is not very charming to automate because it carries a lot of legacy. It's a rather old data service and still very powerful, but you know, not as easy to operate as more modern data services. But also, if you choose a data service and they will change from an open source license to a closed source license, which we've seen with a few vendors, and moving to the SSPL license, for example, that's something that could affect you in a negative way. Striving for full lifecycle automation is basically the idea to know your audience, know what they want, and then provide them with all the use cases that are likely to occur during the lifecycle of your data service instances. On-demand provisioning, we already covered that. Rebuild failed instances instead of fixing them is basically natural in Kubernetes. You don't apply you don't have a stateful set that runs forever and that you'll modify by logging into the pod via SSH and do stuff there. No, if you want to modify that, you basically throw away the pod in the stateful set and recreate it from, let's say, an upgraded a container image, and that basically will also help you through recovery of failures. If a pod fails, it will be recreated. So the idea of an ephemeral pod and its persistent volume, that's basically here. You can take that for granted in Kubernetes. Design for scalability. We talked about many Kubernetes clusters, many operators, and even more data service instances. We should be prepared for that. And each data service instance should be both vertically and horizontally scalable. In the idea of looking at the operational model first is that you understand what the data service does and what are the use cases important to the application developers. And once you know what a DBA and a sysop would do, then you look at the automation. Be a backup and restore hero is if you provide application developers with on-demand self-service, basically they can create their databases. You also need to provide them means to get around failure scenarios themselves. So the more they can do without interacting with human operators, the less waste of valuable work capacity there will be in your organization. In a large organization with let's say 1,000 databases, think about a region with a network partitioning. This could affect hundreds of data service instances simultaneously. There should be automation so that people can recover their service instances themselves. And as beside of clustering and automatic failover, a backup and restore strategy, a solid implementation is a key success factor here. Solving issues on the framework level and fine-tune data service specifically basically means, if you think about the creation of database users, Postgres users in the context of a service binding, that's one of the proposals. Or creating, let's say, an infrastructure or framework to create backups for individual data services with shared code. So anything that you can abstract into something that makes sense across data services, you should do that in a generic way. After automating around a dozen different data services, we know that a lot of things can be generalized. Not all of them but often you can provide a generic strategy. For example, a backup framework that does logical backups will allow you to create backups for, let's say, 80 to 90% of data services. And only a few data services will come with backup strategies that are so specific, they will break your model and you'll have to find a custom strategy and implement it. But it should be the first attempt to make it generic and not get lost in the implementation of a particular operator. Testing is essential. I mean, when dealing at scale with data services, or data service instances, and a couple of them deployed across the globe in various organizations, testing is essential. Not only testing your code, but also testing how service instances are created and whether this thing works in a production environment. And also test desired as well as undesired behavior. Go through failure scenarios like a failing master or a failing secondary and see whether the recovery works as expected, whether failover works as expected. And sometimes even, testing specifically things that are not very well handled in the current automation is meaningful, as you can document this behavior and tell your clients and users about it so that they can try to avoid or at least monitor the environment with respect to more critical situations. Providing meaningful configuration values makes it easy for, let's say, novice users to create a service instance and have, best practice configuration values for free, but also allowing more experienced users to set their, and allow them optimizing their service instances for their particular needs is important. Don't touch upstream source code. If you're using open source data services, don't touch them unless you create a bug report, fork it, or a temporary hotfix. Master release management is about responding to upstream changes. Let's say there's a new Postgres version. How long does it take until you have a new operator? That's an optimization problem. And once you have that new operator, how long does it take until application developers can upgrade their instances? That's another part of the delivery pipeline that you'll have to optimize and be good at. Obviously, iteratively learn, build your automation, apply it to users, present it to users, and learn from their feedback is essential. Documentation we also mentioned. So the last part of our talk today, after looking at some methodological tips on how to approach data service automation, would be technology. In particular, how to write controllers. There are tutorials about this, so we won't show individual lines of code here. It's more about some aspects of writing operators that may, let's say, be surprising or they're worth knowing about. If you take the example of service bindings, for example, that we've presented earlier, the idea was that if you deploy an application, you want to connect that application to a particular Postgres instance, for example. You want to create a database user and you want to have a secret that contains the credentials. A service binding is a custom resource that will exactly do both of that for you. So by expressing you want to have a service binding, you can also make assumptions about the resulting secret, for example, and be sure that when the service binding has been created successfully, that both the secret as well as the Postgres user exist. Now, this will also require you to write the service binding controller. And the service binding controller, the question is, what do you do? Well, you translate the primary resource into secondary resources, which means you create a secret, which is a secondary resource. It's native to Kubernetes. And in this case, we assume there's a custom resource also for the Postgres user, because then our controller here is very simple. All you have to do is create a secret, which is creating, that object specification, as well as a Postgres user, which is another object specification. So the controller, what it does is create two Kubernetes objects and let it reconcile. Now, you don't have to care about secrets because secrets, they are already built-in functionality, but you have to create a second controller, the controller that creates Postgres users. Now, in this controller, the challenge will be you have to access a particular service instance. And therefore, you already have to know where the service instance is. For example, what's the host, what's the username, what's the password, and the user to create users has to have a lot of privileges. So that's something you need to set up. And as one of the problems that will emerge here is your controller should be idiomatic in Kubernetes in the way that it also reconciles properly. So if, for example, the controller has created the secret, and you don't have a second controller for Postgres users, what happens if you've created the secret but you couldn't be able to create a Postgres user? You don't want to leave Kubernetes in an inconsistent state where there is a secret. The application wants to consume the service instance that's behind the secret and referenced by the secret, but there is no such Postgres user. So there are no transactions that will guarantee atomicity among those steps, but with eventual consistency, you'll get there. And in order to make that inconsistent state reconcile, we should be prepared for re-reconciliation in case something went wrong and make those actions idempotent. I mean, that's common sense in reconciling external resources, I guess. So instead of creating a user, you should create a user if it not exists. So that even if the user already existed and you reconcile a second time for whatever reasons, there could be Kubernetes internal reasons, by the way, why a particular object is reconciled twice due to the lack of the Kubernetes caches, that you have to be prepared for that. And then your software shouldn't fail, you shouldn't mess up the status of the custom resources and all that. So be robust by providing idempotent actions is a good best practice. So as I said, caching is something that you may have some problem in the beginning because you cannot mutate from a controller an object in the cache. You basically mutate the object by communicating a change towards the Kubernetes API. And your local cache is read-only. So Kubernetes API will then trigger an event that will then update your local cache. And there's obviously a delay between you modifying the object in the API as well as your local cache being updated. And this replication lag, so to say, the time delay here can also create some problems. So you may want to be aware of that. So let's sum it up. If you work with Kubernetes and you want to create operators, there are many operators. I hope you learned enough to judge about their maturity by, for example, looking what are the capabilities of that operator, whether you compare that to the operator maturity model or to the user requirements we've gathered and presented to you in that slide doesn't matter. As long as you can, understand whether the operator is applicable to your organization. If you're writing your own operator, I hope these rules of thumb will help you to avoid common pitfalls. And if you don't find some of those rules applicable to you, maybe that's because they aren't, maybe that's because you're in a different context, or maybe that's because you don't see a problem that you'll run into later. And that's worth digging deeper and understanding why somebody has chosen to have such a rule. So in the end, creating custom resources and by having custom resource definitions and appropriate controllers is facilitated by using the operator SDK. And if you take some of this advice shared in this talk into consideration, it's absolutely fun to automate the entire lifecycle of data services. I hope you enjoyed the talk. If you have questions, feel free to ask them or reach out. I'm at Fischer Julian on Twitter or at anynines. Just feel free to ask and we'll get back to you. Thank you very much for your time and see you soon.